We're going to look at standard A.7C, which says the student is expected to determine the effects on the graph of the parent function f of x equals x squared when f of x is replaced by a f of x plus d, f of x minus c, and f of bx for specified values of a, b, c, and d. A couple of notes from TEA. And this comes from the Mathematics TEAC Supporting Information document for Algebra 1. Students may be expected to determine changes of attributes, including the x and y intercepts, and students may be expected to apply combinations of transformations. Let's quickly review each type of transformation. So if f of x equals x squared is replaced with a times f of x, where a does not equal 0. If the absolute value of a is greater than 1, it's going to stretch the graph vertically, and the parent function, the graph will be more narrow than the parent function. If the absolute value of a is between 0 and 1, it's going to compress the graph vertically, which means it will be wider than the parent function f of x squared. F of x equals x squared. The opposite of a reflects the graph vertically across the x-axis. Here are some examples of this type of function. So now let's look at f of x equals x squared. What happens if it's replaced with f of bx, where b does not equal 0? Well, if the absolute value of b is greater than 1, it's going to compress the graph horizontally, and it will be more narrow than the parent function f of x equals x squared. If the absolute value of b is between 0 and 1, the graph will stretch horizontally, and it will be wider than the parent function f of x equals x squared. If b is less than 0, it will reflect horizontally. The graph of f of x equals x squared will reflect horizontally across the y-axis. Here are some examples of this type of function. If f of x equals x squared is replaced with f of x minus c, this shifts the graph horizontally left to right by the absolute value of c units. If c equals 0, there is no shift, no horizontal shift at all, no movement. If c is less than 0, it's going to shift the graph left. If c is greater than 0, it's going to shift the graph right. Let's look a little more closely at these two, because this is students are often confused by this type of shift. So for f of x plus 2, the graph is going to shift the absolute value of 2 to the left. Because, let's consider, if c equals negative 2, and we plug in that value of negative 2 for c into this equation, we're going to get f of x minus negative 2, which is the same as f of x plus 2. So the graph will shift 2 units to the left. So for c being greater than 0, let's look at this example. F of x minus 2, the graph shifts the absolute value of 2 to the right. If c equals 0, and we plug in this value of c into this equation, that's going to give f of x minus 2, and the graph will shift 2 units to the right. The final transformation is when f of x equals x squared is replaced with f of x plus d. This will shift the graph vertically up or down by the absolute value of d units. If d equals 0, there's no vertical shift. If d is greater than 0, it's going to shift the graph up by the absolute value of d units. If d is less than 0, it's going to shift the graph down by the absolute value of d units. So let's look at a problem. This is a released item from the 2016 STAR test for Algebra 1. The problem says, function p is in the form y equals ax squared plus c. If the values of a and c are both less than 0, which graph could represent p? So if a and c are both less than 0, that means the values for a and c are negative numbers. Because what type of numbers are less than 0? Think about a number line. Those would be our negative values. Since a is negative, that means that the graph is reflected across the x-axis. So let's look at our answer choices. So remember that the parent function, y equals x squared, opens up. So if we reflect that across the x-axis, that means the graph will be opening down. The reflected graph will open down. So if I look, I can see the only one that's not reflected down is G, so we can eliminate answer choice G. Since C is a negative number, or has a negative value, the graph will shift down. So if we look at answer choice F, this graph actually shifted up. This was a vertical shift up, not down. If we look at H, this is a vertical shift down. And if we look at answer choice J, there is no vertical shift. So the correct answer for this problem has to be H, because it is reflected across the x-axis because the A is negative, and it is shifted down because the C is negative.